today I want to complete chapter 7. So we go 7.2. So hopefully yesterday the work you know how to draw the ray diagram. Okay, so today we go to the chapter 7.2. Okay, there is about the optical instrument. So we learn about three things lah. One should be the microscope, another one should be the telescope, and the last one should be the magnifying glass. Okay, this is a three optical instrument we need to learn for these topics. Okay, now we go through. Wilson is here or not? Tom Wilson not here, is it? Every Friday also not here one. Okay, if not here, so Elaine go to take photo lah. Screenshot.
Okay.
Okay, so Jala still the same, the attendance. Okay, so we continue. Okay, this one is a three instrument we need to learn for these subtopics. Okay, first one, we need to know the name and also function. First one, magnifying glass. They want to observe the small object. Okay, the words too small already. So after that, you want to zoom. So we're using the magnifying glass. Okay, number two is a microscope. They want to observe the specimen and also the object. We example is a microorganism, too small already. Okay, although you're using magnifying glass, you also cannot see. So we're using the microscope. Okay, telescope is the last one. We need to observe the object. They are very far in the space. So this one we call telescope. So these three things also related with what we learned for yesterday. There's a lens. Okay, they're all using the lens. Okay, let's see the first one. Formation of the final image of the microscope. So for the microscope, we're using two lenses. Okay, first one we call eyepiece. Eyepiece lens must the lens near with your eyes. So that means later you all go to observe, you are observe the eyepiece lens. Okay, second one is an objective lens. The objective lens must focus to the object. Okay, so that means the whole microscope actually got two lenses. Okay, let's see how they go to join. Okay, this one is a first part lens, objective lens. So that means the objective lens where they're located, they must located between. You see the object must located between F and 2F. Okay, when the object just located between F and 2F, so where your image must after the 2F. So you can see the image. First one image is a bigger image. They can produce a big image. So the object means there's a microorganism, sure very small one. So after finish one first lens, there's an objective lens. You find the image bigger a bit only. So that means you still cannot see full lah. You still a little bit blur. So that's why we need to using two lenses. So from here you see the image position. This one we call first positions, first image. So image is further than 2F. Okay, what's the characteristic? This one you can follow the yesterday what we learned. When the object is between, then you see the image is a bottom. So this one is a rear inverted. Okay, rear inverted is a partner. Then after that, magnify. Okay, this one is an objective lens. Okay, how about the eyepiece lens? Eyepiece lens is another side. This one is focused to your eyes. Your eye must go to see. Then after that, you see the image. So this one object is between F and also optical center. Okay, now your object is here. Okay, object. That means I can say the image, first image now become the object. Okay, first image now become the object when you go to eyepiece lens. So for the objective lens, you can ignore already. When I just go to the eyepiece, that means objective lens already finished the task. Okay, important the objective lens, they want to focus the first image. Now the first image become object when they go to the eyepiece lens. Okay, now this one is your first image and also you can say this one is a object for the eyepiece lens. Okay, now when I just draw, this one image is here. So they need to start. Okay, this one you how to draw, you no need to know. Important, you need to know objective lens. The eyepiece, you no need to know how to draw. But important, you need to know where's the final image. Where's the locator of the final image. So from here, they're easy to draw only. This one is an object, is it? So you from the center, you just draw. Then from the F, you just draw. Then you sure will cross one. Okay, when it just cross, this one, we call it final image. The final image, when you draw, they must after the object image. Okay, you don't tell me the final image, you are in front the object image. No. Okay, cannot. This one final image must be behind. Okay, behind the F also. This one is a F, is it? They must be behind the F. So that means you get the final image must larger. Okay, now you compare two arrow. The final arrow must be longer a bit. Okay, so that's why they need to using eyepiece. Final image become bigger. So from here, you see the first one, image positions. Image is further than the F. This one image, we call final image, further than the F. What is the characteristic? Okay, now I want you to see this part. Okay, now this part, there's a virtual. This one don't related with before that. This one is another type. Okay, before that I told you bottom sure is a real, is it? But this one also bottom. Okay, no. For the eyepiece, we need to change your idea. Now this one is a virtual. Okay, another one, there's an upright. You see there's a terbalik. Why become upright? Okay, because we compare with the original object. And you see the original object, the head is a top. Okay, final object, the head is a bottom. So we just compare these two. Okay, this one actually is an inverted, is it? Can you see the object original? The head is a up. Then after that, you can see the bottom. This one is the final object. The head is a bottom. So if I compare these two, actually there's an inverted. Yes or no? Okay, but I never compare with the original object. I compare with the first object. Okay, because this one becomes the first object already. So I just compare these two, all the eyepiece part. Don't think about the objective already. We just ignore. So the eyepiece part, can you see two image and also object? The head also is a bottom. So we call it as an upright. Okay, you terbalik, I also terbalik. So that means we two is an upright already lah. Okay, we are same pattern. So they become upright. Okay, so normally virtual, then together with the upright. Okay, then finally I can say they already is magnified. Sudah jadi besar. Okay, so we just compare with the eyepiece, don't compare with the objective already. So we just compare with the eyepiece. Okay, so from here I repeat again. For the microscope, we got two lenses. In front one, sure objective. Behind one, near your eyes one, sure is eyepiece. Okay, objective one, same like what we learned before. The object must located. So this one object is what? This one object is a microorganism. Okay, they must set between F and 2F, the object. So you just draw the line. First ray go to F, then the second ray pass through center. Okay, after that they cross. Okay, so I get the image. So this one we call first image. Okay, where's the first image? They must located further than 2F. Then the characteristic, there's a real. Okay, inverted. After that, magnify. Okay, then this one finish. So I bring this one image, go to the eyepiece. Okay, when this one image, I bring to the eyepiece. Okay, I need to locate it between the focal point and also the optical center of the eyepiece. Okay, so this one become object already. Okay, when it just become the object, so I need to draw the line. First line, you pass center to the head of the object, then go downwards. Another one, you go to behind focal point, you pull until this part, okay, then you pull downwards. Okay, so this one, this point is how to get it. You just put the horizontal line, then you pull downwards. Then you get the image. Remember, this one we call final image. This one final image must further the F. After the F, cannot in front the F. Okay, what is the characteristic of the final? Okay, this one image we just compare with the eyepiece object. The objective one, we no need to see already. We just see the eyepiece. So from here, this one is a virtual part. Okay, this one is a virtual. Then after that, we compare two arrow. This one is a upright. Because you are terbalik, I also terbalik. So we call upright already. Okay, then the size become bigger. So magnify. So the meaning is what? Microscope, when you see the final image, the sure is a virtual. Because microscope, when you're using something to close, you cannot see the image. They cannot capture on the screen. Okay, they just let you to see only. When you just close using the paper to close, that means you cannot see anything. Okay, number 2, there's an upright. Okay, that means the pattern is the same as a microorganism what you go to observe. And the last one, the final image must bigger compared to the original. Okay, they're bigger so much. So this one is a microscope. Okay, now we're going to see the overall. I need to join these two lenses together. Okay, so you remember the characteristic. Okay, when I just join together, they become like this. Okay, I join together. So just now, first part is the objective, is it? Okay, so I draw first ray, I pass the first FO. This one FO, we call it as a focal length. Okay, but this one is a, not focal length, focal, wait, I go to 8 first. Dixon, anything? What, wah for what? Okay, you no need to draw. Okay, I never call you to draw. Okay, you just know how the arrangement. So this one FO, we call it as a, F is a focal point, is it? So I add 1, the O means what? This one is a focal point for the objective lens. Okay, then we got FE. FE, whose one? This one is an eyepiece one. So this one we call focal point for the eyepiece. Okay, so you see the F in front, behind must have lah. Okay, so from here, first one, your object is located to FO and FO. Then you draw first ray, pass through FO, second ray pass through center until they cross. So this one must be located for the first image. Okay, located for the first image. So your first image must be between. This one is the eyepiece center, then this one FE. So this one is your first image must be between this one distance. Okay, now you need to draw the line. First line from the center, past the head, draw straight. Okay, can you see this horizontal line? This one horizontal line you need to draw until they touch. Then you got 1 more point. So that means you want to draw the line at least got 2 points lah. Okay, then it will become straight. Okay, if 1 point, that means I can bend anyway. So I got 2 points, that means I can get the one straight line, follow the shape. So from here, I got 1 point here. Okay, another point is a FE. So I draw 2 points, then I go draw, make it longer. Then until you can cross. So this one we call it is a final image. Okay, this one is a final image. Okay, so from here, you're going to see the characteristic. Okay, this one is a final. This one is a first. Okay, so follow your textbook. They compare with the first image. So they become upright. Okay, they become upright. So from here, the final image is a virtual, magnify, and upright. So I teach about how upright first because I want to confirm is it correct or not. Okay, for me, I not accept lah. For the physics, sure, it's an inverted one. So I need to find out the teacher teaching about the science for many years. I'm going to ask, is it this one accepted for the science or not? Okay, for the physics, memang cannot accept lah. Okay, so from here, we just compare with the first image. So we find it there's an upright. So if you compare with the object, original object, sure is inverted. Okay, so from here, characteristic, we just accept first. There's a virtual, magnify, and also upright. Okay, so from here, this one is a diagram. You no need to draw. Okay, no need to draw. Just you need to know what is the final characteristic. Okay, final characteristic. Okay, so we go through to the, okay, I think, wait because I find yesterday, I go through your reference book. Reference book also said inverted. Follow here lah. Okay, you just ignore the textbook lah. I go to find out final, I told you what's the answer. So I just follow reference book, they also give inverted. Only your textbook lah. This one is a textbook, is it? So the textbook give me the answer is upright. Okay. So from here, maybe upright, that means this diagram only lah. This diagram is upright. When they just combine, then cannot say upright already. When B diagram, yes, there's an upright. So when combined together, that means we need to see overall. Okay, when we see overall, then we say inverted lah, because this one, last one, compare with the object. Okay, so just now, okay, is separate. Okay, so you don't think just now the characteristic, we think about the last one is overall diagram. Overall diagram, that means you need to remember. You can see here, got so many exercises already. Okay, this one is an overall diagram. Final sure is a virtual already. Okay, then sure is a magnified. Then you help me to add inverted. Okay, then you will ask, virtual partner bukan upright ke? Yes, virtual partner memang is upright. But the problem is now I compare the original object and also the final image. Okay, I didn't using the first image to compare. I compare the original and also the final. So I get it, that's an inverted. Okay, so some will ask, if inverted, that means later I see the thing that terbalik. Can what? Microorganism, you also do know terbalik or what law? When they upright, when they terbalik, you also do know law, because microorganism. Okay, you see the bacteria, you see the virus, you also do know terbalik or what? So that means the final answer sure is a inverted. Okay, but you see camera cannot law, camera must be upright because you want to take photo, is it? So you don't say you final image for the camera, the head is the bottom, so no. So camera must be upright. For the microorganism, because they never go to observe the people, they just observe the cell. The cell terbalik, also never mind. Okay, so remember the final image is a virtual, magnified, then inverted. Okay, we follow here. Then we go to the microscope, we finish. Okay, then we go to see this one is the original microscope. So this one is an eyepiece. This one is what you go to observe. This one we call objective lens, because this one is a focus to the microorganism. So from here they say, microscope containing the eyepiece with the magnifying power 4 times. Okay, magnifying power is a 4 times. Okay, times 4. And the objective lens with the magnifying power is a 40 times. Wow. So that means objective lens is very, very focusing. Okay, they make it very zoom. Okay, make the power become 40 times. Okay, so from here, we're going to see this one got one calculations. Magnifying power of the microscope, overall magnifying power. How to do the calculations? So you need to take magnifying power of the objective lens, that's a 40, multiply magnifying power of the eyepiece, there's a 4 times. Okay, if the question asks you like this one microscope, okay, magnifying power is how many? Then you need to multiply these 2 lenses. Okay, not only for eyepiece, not only for objective lens, but you need to multiply. So from here, the question will provided objective lens how many times. They also will provided the eyepiece is how many times. So we just combine, multiply. So they take 40, multiply 4. So overall, the magnifying power is how many? 160 times. So that means the microorganism can make it bigger 160 times. Okay, so that means depends, important, it depends your objective lens. So if your objective lens is very large, that means overall is very high already. Okay, eyepiece just a little bit. Okay, so this one is one of the calculation you need to do later. Okay, so this one is a microscope. Okay, now we go telescope. Okay, Dixon, later you see the telescope, you like, wow. Okay, so we're going to see telescope also using 2 objective lens and also eyepiece. Okay, separate first. Okay, objective lens, that means now you want to observe the star. The star is very far. So that means the object now is infinity. The object is very far, infinity. So infinity, that means we cannot draw lah. We don't have any object, infinity already. So we draw parallel line. Okay, parallel line means the object is very far. So the first parallel, you just draw one straight line, go to F. After go to F, you draw horizontal line. Okay, second line, you just parallel. Can you see the purple color and the pink color is a parallel? How far is up to you lah. Important is parallel. Okay, when you're just touching until the center, then you go straight. Go straight only. This one just like the second ray what we draw. Okay, go past center, then go straight until they cross. The cross must at the F. The cross for the first image must located at the F. Okay, just now no. This one yes. Okay, exactly at the F. So you go to fix lah. If they call you to draw the first objective lens, you go to fix your image is located at the F. So after that, you draw the line, also can. You want the terbalik to draw, also can. You fix the image, then you draw the ray. Okay, or you draw the ray, then you fix the image. Just like this only. So normally, you want to exactly at the F, better you draw the image first, then you draw the ray. Okay, because later when you just draw the ray, you cannot cross at the F. So better we go to set at the F first, inverted. You draw one arrow inverted. After that, you terbalik draw the pink color line and also the purple color line. Okay, now the image of the position for the first image must at the F focal point. Okay, this one is an objective focal point. What is the characteristic? Real inverted. Okay, at the bottom, real inverted, then diminish, because this one further object sure very large. Okay, the star, the moon sure very large. So the first image you get it is a smaller. There's a diminish. Okay, then we go to the object after eyepiece. Go to the eyepiece. Okay, so I bring just now the image, go to the eyepiece. So located at the F, is it? So I just draw from the center, go to the F, one straight line. Okay, then you draw the horizontal line, go to the center. Okay, after that, you continue past the F, draw one straight line. And you see both cannot touch. Down cannot touch, up also cannot touch. 2 is a parallel line. Parallel, what's the meaning? Parallel means very far. Okay, when you see parallel, sure it's a very far. Okay, so that means where is your final image? Your final image also very far. So there's a infinity. Image position now is a infinity. So that means later you go to observe the star, you also cannot capture because very far already. Okay, the image is very far. So characteristic, virtual, upright, magnified. Okay, the upright later will change because when you see this one diagram, there's an upright. Okay, later we need to overall. Okay, we see the overall first. Okay, overall. Wow, overall. Okay, overall, this one is an object. This one is an eyepiece. Okay, so line, we no need to remember how to draw, but important, you need to know where is the first image. The first image is located exactly the F. Okay, after that, you draw the line parallel, then this one is a final. Final cannot focus one, just parallel only. Okay, so from here, we need to mention is virtual. Final image, we're talking final one, virtual, magnified, inverted. Okay, same like the characteristic for the microscope, exactly the same. Okay, then after that, we're going to see this one final, the first image, final image cannot capture, so no need to draw lah. There's an infinity. Okay, what is important for telescope? They will ask about the calculations. There's a FOFE. Okay, FOFE. 2 distance between the lenses. Okay, can you see FO plus FE? There's a exactly distance between the lenses. Okay, so this one we call what name? This one we call normal adjustment. Okay, when they just create like this, normal adjustment, that's why the final image is infinity. Okay, if they never create like this, they cannot get infinity. So they say normal adjustment, the meaning is distance between the objective lens and also eyepiece. So there's a FO plus FE. Okay, normally the FO is a longer, FE is shorter. Okay, so for the telescope, must remember FO must longer than FE. Then two distance is how many? Two distance is a FO plus FE. Only for telescope. Microscope, no. Okay, I show you back microscope how. Okay, I turn back for the microscope. You see the microscope. Okay, microscope, this one is FO, is it? This one is a FE, is it? I go to draw. If I go to draw, I go to draw, need to draw straight line. Okay, this one is a FO. Okay, this one is a FO. Okay. Okay, this one FE. This one is a distance. Okay, so you see the two distance between the two lenses. This one is a FO. This one is a FE. Then not FO plus FE. Can you see the center got one space? This one is a microscope. If I say distance between two lenses for the microscope, FO plus FE, wrong. Because center you still got space. Okay, why the microscope create like this? Because they want to focus. They want to get the final answer. They want to focus. So center, they got one of the space. Okay, if I say FO is 20, FE is 30, so distance is how many? Distance sure more than 50 lor, because center, they got one space. Okay, another thing you need to focus, for the microscope, FO is shorter. FO is expanded. Okay, FE is longer. Okay, this is a microscope. Okay, then we go to the telescope. Okay, just now the telescope, we go back. Okay, telescope. Can you see there's a exactly FO, FE? This one is a, wait, I draw. So this one is a FO. FO, from the FO, then go to the objective. This one is a focal length for the FO. This one is a FE. Okay, can you see FO and FE, they share same point? Okay, located at the same point. After that, two distance, exactly FO plus FE. Exactly, FO plus FE. Okay, don't have any space. Then you must know the FO now is longer. FO now is longer than the FE. Okay, FO is longer than the FE. Then final image cannot focus. That's a parallel. Okay, so this one is the differences, telescope and also the microscope. So from here, microscope, no calculation. They need to multiply. They want to multiply the magnifying power is how many. Okay, for the telescope, we never multiply. We only want to calculate normal adjustment. Okay, we want to count the normal adjustment, means FO plus FE. Okay, so FO stand for focal length objective lens. FE stand for focal length for the eyepiece. Okay, both also got objective, both also got eyepiece. Okay, but the differences is a FO and FE. Okay, for the microscope, FO shorter, FE longer. Okay, telescope is terbalik. Okay, another one you need to know the distance adjustment. For the microscope, they got one extra space. Okay, why they got extra space? Because final they want to focus the image. Okay, for the telescope, they don't have any extra. Exactly, we call it normal adjustment. So why they no need got space? Because final, you see, they no need to focus what? Finally, they just want parallel. Okay, so final image characteristic is the same. Virtual, magnify, inverted. But the telescope, you need to add one more lah, because the final image is infinity. Object infinity, final image also infinity. So that's why you see the any space, the thing, all is an infinity very far. So we cannot focus one. Okay, then you say the star inverted, can see the star inverted, the moon inverted, we also do know, is it? So that means microscope and also telescope, the image sure infinity. So sorry, sure inverted. Okay, sure is virtual because we cannot capture. Okay, then sure magnify. 2 also must be bigger. Okay, so this one is a telescope and microscope. Okay, so must you recall back what's a microscope, what is telescope. Well, later I will share about the video. Okay, application for the lens is an optical instrument. Okay, technology advancement in the field of the optics. They have enabled the lenses. This one your handphone. They use an optical instrument such as a smartphone. Your smartphone can zoom. After that can wider some more. This one, and also the closed circuit for your TV. There's a CCTV to be only several millimeter thick. Although they can observe so many things, they can zoom. After that, they can make it become further. Then you see the thickness very, very small only. So from here, the flat lenses, okay, with a thickness of the several microns only. You see how small. 1 micron is 0.001 mm and used in many optical instruments. Okay, so that means they can modify now already, make it become thinner and smaller. Then after that can fix in the CCTV and also your smartphone. Okay, all is a lenses. Okay, so the flat lens in a smartphone enable the camera to focus, to be maintained the focus free, and also producing the sharp and also clearer images. Flat lens make the smartphone to be slimmer and also lighter. Okay, no need to take microscope. Microscope memang lah, they want to focus microorganism, is it? But your camera cannot focus. Okay, but this one your camera already advanced because they can zoom. Okay, they also can be wider and also double zoom. Although double zoom, they still become clear. Okay, so this one is the flat lenses they're using for the microphone, for the smartphone. Okay, so these are the application for the lenses for the optical instrument. Example, you got CCTV. So your camera, okay, this one camera sure better than your phone one because the inside the lenses is very high objective lens. Okay, after that we got this one is a spy camera. Okay, CCTV, then the digital camera. After that, the last one is a spy camera. Okay, these all using the lens. Okay, so we're going to see the image from the different focal length. Okay, now we're going to see the first observe. This one is you can zoom. Okay, that means you find very clear, but the object clear, the area less. You only can focus the playground. Okay, when you're using the focal length, is a different. You can see the playground become blur already further a bit, but you can observe more area. So this one is see the focal length different. Camera image formed using the focal length 70 mm. Okay, from a distance 15 meter. Okay, another one also distance 50 meter, but focal length is 24 mm. The focal length becomes shorter. Okay, you can see the area become more. The area become more, but the object becomes smaller. Okay, so when the focal length become longer, 70 mm, okay, you can find your image become bigger. Okay, but the area become less. Okay, so conclusion we can say focal length longer, focal length become longer, image is big, large. Focal length become shorter, the image become smaller. Okay, the distance is the same. We never adjust the location when you take the photo. Okay, just adjust the focal length. Okay, focal length become smaller. You find it, the image becomes smaller also, but the area is wider. Okay, so this one is a different focal length, different the image you can get it. Okay, we just until this part. Okay, so what you need to do, please, if you don't understand about the telescope and microscope, please recall back. Important, you need to know what's the differences. Okay, what's the differences for the FO and FE? That one will cause about the final image. Final image, although it's the same characteristic, just one infinity, another one is no infinity. Okay, and also you need to know the formula for calculations. Okay, so what you need to do, first one, 7.2, formative practice. Second one, already in GC, there is this one exercise. Our lesson just until here.